So now we're on part 2 of our discussion of streams reduce, the streams reduce terminal operation. And we're going to take a look at a couple of interesting variants of collect and reduce, just to mix things up in very curious ways. So I've been talking here a lot about how reduce is usually applied to produce a single value, often a primitive. Doesn't have to be a primitive, but could be a primitive. Interestingly enough, you can also use collect to return a primitive value. Not the most common way to do things, but it's certainly possible. So here's how we could use collect in lieu of reduce. So as you can see here, we've got our matching characters map. We create the values collection, turn it into a stream, and then we collect the results using summing long, which is going to take all the elements in the stream and sum them together using this particular conversion operation, which will convert the long, capital L, elements in the stream to the single lowercase value long result. So that's how we can sum things up into a single primitive using collect. Probably not the best way to do things, but it works. So if you only know collect, then this is the way you probably do it. So keep in mind that collect terminal operation triggers the stream processing, and then summing long is a factory method defined in the collectors utility class that returns a collector that will sum things up into a lowercase l long value. Now, also interesting, reduce can be used to return non-primitive values. The bulk of the examples we've looked at so far have been using reduce to apply primitives like lowercase l long. But you can also return non-primitives, and here's an example. And you can see this example. This is in a slightly different project. This is my EX17 project in the Java 8 folder in my live lessons GitHub repository. So what this thing is doing is it's going to take it's basically a list of words and convert it into a stream of words. So now we have a stream of words. And then what we're going to do is we're going to go ahead and create a single string that contains all the concatenated words in a stream. So here's how this is going to work. So we're going to take string stream, which was initialized up here. Whoops. Up there. It should be red. And we're going to go ahead and give it a string as the initial value. So we make a new string as the initial value. That's what's being initialized there. And then we're going ahead and we're applying the plus operation. Now, if you remember much about Java strings, the plus operation in a Java string will concatenate string x, or actually concatenate or append string y at the end of string x, making a new string. And always remember, with Java strings, they are immutable. So once you make a string, you can never change the contents of the string. You can only make a new string that contains the contents of other strings. So one of the consequences of this is that this particular way of doing things with the plus sign is not going to be particularly efficient. So be aware of that. So if you start using reduce with non-primitive types, there may be some overheads that you're going to not appreciate. And there's also some other subtleties when you start dealing with other data types that don't work properly when they're run in parallel programs. We'll talk about that later. So how do we fix this problem? So yes, you can use reduce to make a string, but it's not going to be efficient because adding two strings together or concatenating two strings together is not very efficient. So then we can go back to using collect again, and there's another collector called joining. And we took a brief look at joining much earlier, but now we're going to look at it in more detail. So this is going to go ahead and concatenate everything together so we can join all the elements in the stream together. And this actually internally it uses a mechanism that doesn't make copies. The problem with the concatenation operation is it makes a copy, and that can be expensive, especially as strings get big. By using joining, on the other hand, a copy is not made. It basically appends things into a clever buffer, like a string buffer kind of thing, And then when it's all done, the last thing it does is it takes that string buffer and turns it into a string. There's only one copy operation made as opposed to repeated copies. So it'll be a little bit more efficient. Yet another thing to notice is that, remember I talked before about how terminal operations typically yield non-stream results? Well, here's the counterexample. Here's the exception that proves the rule. The reduce operation, when given stream concat as a parameter, will return a stream, which is the concatenated stream, and therefore we can have a terminal operation that returns a stream, and then we can go ahead and use another terminal operation after it to do something to that stream. So that's a little bit esoteric, but it's kind of fun to know. So it's not always the case that every terminal operation returns a non-stream result or yields a non-stream result. Okay, so that's the end of the discussion about reduce. From a programming assignment point of view, by far, collect is the thing to be aware of. And the great news is that the collect operations or any other terminal operations that we'll be dealing with are going to work with both parallel and sequential streams. So that's very helpful. You don't have to learn a whole new set of things.